Great, great. Thank you, Rebecca. And hello to everybody out there. I can't see you, but I know you're there. And do appreciate you taking time to learn about a decision model for resilient communities. My name is Doug McClintock. I'm with Storm Sensor. We are a Seattle-based climate technology company focused on helping cities and agencies deal with flooding. And I'll tell a little bit more about what we do toward the end of the session. And if you have questions, I'm happy to answer them too. But today we're going to be talking about this new model for flood risk, ecosystem services, and property values. So we're going to talk about how these things kind of interplay when it comes to community planning, and especially planning for resilience, and in this case with respect to resilience against flooding. So in my work, I come across a lot of stormwater plans and water management plans, resiliency plans for cities and agencies. So I know a lot of you are probably involved in that to some degree. In this age of climate change, you know, we are making plans to be more resilient, whether that's flood resiliency, drought resiliency, emissions, a lot of different things come into play. But again, we're going to be talking about flood resiliency and how your planning should really consider both the physical and the social risk of flooding. We're also going to talk about how ecosystem services can provide value in that, and in the importance of considering untouched ecosystems when it comes to planning for flood resistance and balancing that with community growth and expanding development. And then finally, we're going to talk about how you can visualize flood risk as well as ecosystem services values and property values to come up with a decision matrix to really help you more effectively plan for flooding prevention. So a little bit about climate resilience. I'm sure we've all heard this many times. And to me, it's not just the ability for a system or city to cope with an event, but to me, it's really about the planning that you put into it. And that's where this model comes into play. It's helping you plan, providing you with the information to visualize your systems across the community and to be able to be more resilient as a result of that. So let's talk about climate change here a little bit. So needless to say, I think a lot of you folks are probably in California, so these are by no means foreign to you in any way. The heat, the prolonged drought, the wildfire seasons, more intense rain events, things like sea level rise. And then with these, you've got the challenges of aging infrastructure, and then the loss of natural areas due to development. And just for fun, on the side there, I've got two pictures. Both of those are Sacramento. I think a lot of you are from the Central Valley, Sacramento area. And that first one there you may recognize is from the Great Flood of 1862. That's K Street in Sacramento. And then down below is something that we all hope will never happen, but that is someone, I think, created this picture to show what might happen if Greenland were to totally melt out. I know that Sacramento is largely protected by levees, which is great. But again, we're seeing more, not just the river threat, but we're seeing threats from increased rain events. I think about a year ago, Sacramento received 5 inches of rain. There were also significant flooding events in 86, 95, 97, 2006, and 2017. And I know as a result of those events, a number of cities, I think Roseville in particular, has done a great job at reinforcing systems there to make it more flood resistant. So despite that, though, the type of flooding that we're talking about really is not just river flooding. And here I'm showing some pictures of the FEMA flood map for Sacramento. Then this one over on the right is from the city of Sacramento, showing what it would look like if there weren't levees in place. But really, in terms of urban flooding, what we've seen working with different agencies and cities, it's really the intense rain events and the aging infrastructure that is causing flooding in a lot of communities. So I think this is a great definition that urban flooding is not just what happens when a river overflows or a storm surge from a hurricane. It's really where the water, as you guys know, doesn't have anywhere to run off, and you have inadequate infrastructure that can be easily overwhelmed. And especially you're finding this in the more vulnerable neighborhoods of cities. So FEMA maps. FEMA maps have been used for many years. They have served a purpose very well in terms of determining insurance rates, but I don't think it's going to be any big shock that a lot of the FEMA maps are considered out of date. Even the Homeland Security Inspector General report from a couple of years ago said that about 2/3 of the maps had not been updated in the last 5 years. The other thing is FEMA maps typically look backwards. They look at frequencies of floods. So they look historically, not necessarily forward, and they don't always consider changing land use patterns, such as more impervious surfaces. Also, our research has shown that over half of the flooding events are occurring outside the 100-year flood zones. And as testament to that, nearly half the claims in Houston prior to Harvey were outside of these zones. So it really becomes important to kind of look at new models, new approaches to determining flood risk and making good infrastructure decisions based on that. And so what we've come up with here at Storm Sensor is a new model that not only considers the physical risk, but it also considers the social risk. And more importantly, it's not necessarily whether an area is at risk of flooding so much as it is what is the impact of that flooding? How will it affect different populations in different portions of my city? So with that, we introduced a new map-based model that we call SURFR. SURFR stands for Stormwater Urban Flood Risk. It's a map-based index where you can divide your city up into a number of tracts, by census tracts or other geographic designations. We call them risk management zones. And by clicking on any of these risk management zones, or RMZs for short, I can come up with a scoring matrix showing both the physical hazard score as well as the social vulnerability score. And I'll cover some of these things here in just a minute, so it makes a little bit better sense to you. And I'll also go through some live examples and some screenshots for the city of Sacramento, just to give you a feel for how this index tool can work. So SURFR is map-based. It's really intended for community planning. We include the socioeconomic data as well as the physical hazard data. We try to keep that data as up to date as much as possible. We also account for climate change projections. So some of our coastal communities where we've done this analysis for will take sea level rise into the picture. And then finally, as I said, you can divide up the geography however you wish, whether it be a grid, census tracts in the case that I'm going to show you today, or some other type of designation, even down to the parcel level. So why SURFR? So as I said, we're seeing a lot more flooding outside the 100-year zones. We're also seeing a lot of flooding occur in more vulnerable communities where aging infrastructure is. And this tool can be used then as a decision tool with some other tools that I'm going to show you today to prioritize where do you want to do capital spend. You know, what communities are most at risk? How can you preserve any natural areas in your community that are already providing natural flood mitigation? And then you can also use it to prioritize green infrastructure projects, which a lot of cities are doing these days, and a lot of these are very successful efforts. So as I said, SURFR includes a number of physical factors. We include some physical factors you don't find in all models, such as imperviousness, tree canopy, and as I said, sea level rise. Then you have CDC has a social vulnerability index, which consists of about 16 individual factors. We weigh all these factors, we can combine them into a final score. We also give cities the ability to compare our scores with FEMA if FEMA were to assign scores, which they don't actually do, but I'll kind of show you how that works. So here are the physical factors, things of course like elevation, slope, imperviousness, tree canopy, topographic wetness, that's kind of the ability of, or it's kind of the accumulated rainfall that you might see in an area and how well it drains. Social vulnerability consists of these factors such as income levels, single parent households, multi-unit dwellings. We weigh all those in and we come up with a scoring matrix that gives you both the physical risk and the social risk scores. So here I want to take you to a live map. I'm going to kind of bounce around a little bit on this, and then I'll take you, and then I'm going to show you some specific examples. And for many of you, you obviously recognize this is Sacramento and Folsom Reservoir up here. So if I click this, it should bring up a live map, and hopefully you guys can all see that. Let me know if you don't. So this is a live map. I can zoom in, zoom out, and I'm going to move my screen there so I can see this. So this is the surfer analysis, and the color coding is pretty intuitive. The red is the higher risk, yellow moderate risk, and then green is very low risk. So I can click on any of these census tracts and come up with the scoring. So for this one here in North Sacramento, for example, we see a pretty high vulnerability score based on these factors: disability, unemployed, no vehicle, below the poverty level, and then we see some kind of moderate physical hazards. Conversely, though, if we click on this one way out here, come on, it has a surfer score of 1. Well, why is that? If we were to zoom in on Google Maps and look at the land here, we see it's a lot of vacant space. Not a lot of dwellings, so the risk is very, very low from both the physical standpoint and the social vulnerability standpoint. Okay, I can also compare this to how FEMA might assess this. So FEMA assigns a water risk to the Natomas Basin, but in the core of the city, thanks to the levees, it has very low risk score for the most part. Then I can also look at a comparison. With the darker purple is what we rate, our model surfer rates is higher, whereas the lighter up here in the Natomas spaces, FEMA would assign a higher degree of risk, and we can see what those differences are. So I'm going to close this out right now and jump back so it's a little bit easier to follow. And I want to just show you some specific examples here for Sacramento. Okay, so first off, here's the surfer and FEMA comparison. It's a little bit easier to visualize when I bring up both of these pictures in the same screen. So here again, a lot of high risk up here according to FEMA, and then we on surfer side assign a little lower risk. So why is that? Well, we don't disagree with FEMA that these areas may be prone to flooding, but as I said earlier, it's really the associated risk. What is the risk of that? Is it based on the population densities, other social factors, other physical factors? So it's really more the impact in some of these areas that we differ from FEMA. We say that the associated risks are not quite as high. Then looking at the comparison, again, we can see this area is definitely rated higher by FEMA, whereas the core is rated higher by the surfer model because of those social factors primarily. Okay, I want to zoom in on an area here. So this green, relatively low risk. If you're familiar with San Diego, that's I think it's the Curtis Park neighborhood. And if in the live view, if I were to click on that, this is the scoring that I would come up for that census tract. So very, very low on social vulnerability, very, very low. And pretty low on the physical hazards. So the elevation relative, now again, this is all relative to other RMZs in the area. So relatively lower elevation, or elevation score is lower, meaning it's higher elevation. Proximity to surface water, namely the Sacramento River, American River, is pretty low on that. And then some other factors like the paved area or imperviousness is relatively low in that as well. And I think if you know Sacramento, there's a big park in that particular tract. Okay. Conversely, though, if we look at this zone right here, this is the highest of all the zones according to the surfer model. So very, very high, the highest of the social vulnerability score based on these factors of unemployment, single parent households, lack of vehicle, and then also on the physical hazard score, it's pretty high too, elevation in particular. Then if we get back to the core of Sacramento, here's Capitol grounds. Here we can click on this one. And I brought up a map-based view here, so now you can see the streets and get a better feel for the topography, although I'm sure many of you know Sacramento much better than I do. But anyway, if I click this, I get a moderate score of 64, pretty high on the physical hazards, but again, we're not necessarily taking into account the levees here. We're just really more taking into account the proximity to the water and elevation. And then on the social vulnerability, that's relatively low, not too high. We're right there in the core of downtown. Okay. Another interesting thing I found is comparing what the risk model in Surfer compares to the unfortunate practice of redlining, which occurred back in the 1930s. But as you can see, some of that lives on here, especially in these areas of garden land in Old North Sacramento, which are right about in here on this map on the left. And if any of you are interested, this was a Redfin study that was done, and I got it off of Bloomberg, but it's a very, very interesting study that not only profiles Sacramento, but a number of other US cities. So if we look at one of those scores here, for example, up here in North Seattle, like this one, this tract right here that's kind of outlined in blue. Again, we come up with a very, very high vulnerability score on that, and moderate to higher elevation score. And then conversely, looking at those areas that were identified as desirable neighborhoods, some interesting data and stats on that. We can look back again, like at Curtis Park right here, which corresponds to this map here, right there. And I already showed you this score earlier, but it was pretty low. It's the overall score of 18, which is about the second lowest relative score for Sacramento. So a lot of insights that you can get from this that help you kind of visualize what areas of risk, what are the associated risks, and what are the impacts if there were flooding in these particular areas. And another thing that we've added to our model is to the ability to display critical infrastructure. This is relatively new. Just something to note, where, hospitals, like this is Mercy Hospital right here, where your fire stations, your police stations are relative to the degrees of risk. And then we can also break out each individual risk factor. So this is displaying social vulnerability, elevation, slope, soil drainage, imperviousness. And so you can see which of those factors, in a map view, were possibly contributing to the highest overall score. And actually on this next screen here, we break that out for you. So we show for Sacramento, social vulnerability, slope, and imperviousness, and to some degree tree canopy. Although I'm not quite sure if I agree with that, but these three here are very, very high in terms of what's not captured by FEMA, whereas FEMA is looking at proximity to surface water, your flood zones there along the rivers, and soil drainage. All right, so we're going to take things a little step further here, and I forgot to set my clock here, so I think we're doing great for time. So here we're looking at kind of a way to approach resiliency planning. So we've looked at flood risk. Okay, we've prioritized flood risk. We've been able to see what areas are highest degree risk. Now we can look at property values and ecosystem services and see how they kind of play out into the planning. And then as a result of that, we can start to adapt. We can make plans for where we might want to implement gray infrastructure improvements, green stormwater infrastructure improvements, and such. Okay. Now I'm gonna change things here a little bit. I apologize. I wanted to get data for Sacramento, but we weren't able to get the property data, or at least get it in time for this presentation. So I'm going to show you what we did, a similar analysis for the city of Spokane, Washington, based up here in Washington, where I presented this a couple of weeks ago at a conference. So a little bit about ecosystem services, if you aren't familiar. So the EPA defines ecosystem services as those kind of life-sustaining services, goods and services that we all receive from nature. In the context of this discussion, though, we're looking at regulating services down in the lower right, specifically flood regulation and how ecosystems can provide that natural flood prevention. Ecosystem services, if you aren't familiar, I mean, they can actually be valued. This is kind of the domain of economists, so I can't go into any great detail on how they do it. But it's a very interesting science, and it's something that's getting a lot more attention, I think, in various academic and circles these days. And this is just a chart of showing what ecosystem services have the highest versus lowest value. And then we compare that to the appraised property values. This is on a per acre basis, right? So we can see things like coastal wetlands, coral reefs are among the highest, whereas deserts, shrubland are among the lowest. Likewise, the vacant land offers a lot of opportunity for resilience on the property values, whereas the residential single attached homes have among the highest, and therefore the highest degree of risk during disasters. So here's a similar map of Spokane showing the relative risk. Just for perspective's sake, this is Interstate 90, the pink line going down through the middle, and then we see the Spokane River just above that. And we can see this downtown core has a lot of red, meaning very high risk. Even up extending north of the city a bit. This area up here happens to be a very high elevation community of homes, so it's relatively low risk down there. So what we did in the case of Spokane is we mapped out both property values and ecosystem services. So first, the property values. We can see that in that core, the darker color here are going to be your higher value properties. Whereas we get out into the outer regions, a little lower value property, maybe because of vacant land. And then likewise, the ecosystem services kind of correspond with that. Your high value ecosystem services are going to be more in the exterior parts of the city. This is a drainage here in this lower part, Spokane River. This is higher elevation up here. So if we bring these two things together, our data scientists have kind of merged these two things together to come up with a decision matrix. And that decision matrix looks like this. So what we get is a map showing you where your high loss is, and that is what areas of the town have low ecosystem services values, but a high appraised property values. And then conversely, your high conservation areas, these are areas you might want to consider for preservation if you aren't already, are going to have your lower ecosystem services values, high ecosystem services values, but low appraised land values. And again, you can see how that corresponds to this drainage area here along the river to some degree. And then there's pockets of green throughout the city. And obviously, if you zoom in on this, since this is at the parcel scale, you're going to see a lot more in there, which I actually break out in the next slide. So if you look at high property values where there's going to be high loss potential in the event of flooding, you can see that that's about 18% of the city. whereas the ecosystem services values, the ecosystem or high conservation areas comprise about almost half of the city. But again, kind of in these outer lying regions. Okay, so what I want to do next is kind of take you through a couple projects based on both our surfer analysis and our property and ecosystem services analysis for the city of Spokane. I'm going to talk about two projects that I came up with that I think might be potential projects for the city. I'm not a city planner, but these are areas that our model showed might be worth taking a look at if the city's not already doing so. And then secondly, two completed projects the city has done over the last 10 years that I think really illustrate this planning that we're talking about in this model. So first off, we're going to look at some urban flooding right kind of in the core of town. I've outlined this white area here. This is actually a single census tract that kind of extends pretty far north of here. But the flooding occurred right about here. I can get my laser for you. Right about in this area here, kind of right on the edge of these two tracks, right near Interstate 90. And here's a picture for you in the lower right. It's on Maple Street, right at the intersection of Interstate 90. And this, interestingly enough, is a picture of flooding that occurred just this year in May when Spokane had some very intense rain. Now, Spokane is a lot more like California. It's on the eastern side of the mountains. It doesn't get a whole lot of rain compared to Seattle, where I live. But this area here not only flooded this year, but several times before. And as a matter of fact, it flooded a kind of a lower income apartment building, old brick building, just kind of to the left of the picture that we can't see. And so they had basement flooding that occurred back in 2018. So this is a known area. Well, it's a known area that has repeated flooding. So that's why I decided to focus on this in particular. So here's satellite view. This is the area of concern, Interstate 90. This actually is that apartment building that was flooded once before. And then here are your surfer scores for actually two different census tracts. This is the census tract where the flooding has occurred. But this is the one right next to it, more in the center of town, urban part, which does have very high risk. It's almost at 100. And the reason I brought both of these up is because this census tract here, as I said earlier, extends pretty far north. So I don't know if the scoring, if we were to like go more granular, maybe by parcels or grid or some other geographic designation, we might see a little higher score in here, especially on the social vulnerability side. So next, what we did is we looked at the property values. So these are considered high loss. So it's high appraised value, would be high loss in terms of flooding. We also mapped out the conservation areas where there's potential ecosystem services values. And as you can see in this little triangle here, which is the area of flooding, there's not much, there's nothing pretty much. So with that said, then, combining these two, this would be, to me, a good target area for either, and gray infrastructure improvement and or some type of green infrastructure, maybe some more vegetation in the sidewalks to drain off some of that stormwater, perhaps. Here, I think as you go south of here, you're kind of starting to go uphill. So you're seeing probably a lot of drainage come down from this direction and maybe from other sources in here too, just being a low-lying land. Also an area, according to one of my people in the audience from my Spokane presentation, he said this is an area that's been very, very neglected in terms of infrastructure improvements over the years in Spokane. So that's probably why they're seeing that repeated flooding. So to me, a great target area for some type of maybe green infrastructure in this particular area. Okay, the other example I have is just a bit south and east. This is an area that has also seen flooding. Here I bring up a picture that was just from this year of flooding at this particular intersection. And there it is on your satellite view there to give you a perspective. Interstate 90 up here. You do see we have some green space in here. We have kind of a green area in here, community park. And we'll talk about that in a little bit. And then here's our surfer score. So very, very high score, 87, very high on the social vulnerability, 50 for this particular census tract here. So definitely an area that, you know, we may want to target as well for improvements, since there is an at-risk population there. Here's our high values of our properties for this area. Your high conservation areas, as I said, there's a lot of green in here, open space, community park. And then bringing the two together, we can kind of see how those mix. Here's our flooding area. And then based on that, again, I would say this could be a great area for some improvements, maybe some more improvements up at these vacant area here, this community park, perhaps some type of additional projects that could be done to reduce the runoff going down here into this neighborhood. So those are two examples that I don't know if the city is currently thinking of doing, but just things that I think, based on our model and analysis, could be potential areas to address. And then last, I want to show you two things that the city has done that I think also illustrate this planning model. The first one is a natural stormwater facility that the city preserved about 10 years ago, kind of on the far south of the city. It was an existing drainage area that had been vacant for many, many years. Had kind of farm at one time, and they decided to preserve this site to reduce the runoff going into the city. And it's been a great example for the city, kind of a showcase example. It's actually a low impact demonstration site. They have a number of exhibits in this area, such as rain gardens and rain barrel collection and other best practices to show citizens how stormwater can be mitigated in these natural ways, which is very, very cool. But the big thing is it's providing a natural flood mitigation for drainage that's making its way down here into the city and eventually even into the Spokane River. Okay, next example is something that's I think really, really interesting. This is an impervious pavement project that they started a couple of years ago. They took a section of this avenue, Sharp Avenue, which is just north of Gonzaga University. So if you follow college basketball, you should know Gonzaga. So this is an area that is relatively low elevation based on the scoring here. I think we have an elevation score of about 13, proximity to surface water. It's very close to the Spokane River. Slope comes into play, and definitely imperviousness. So taking these factors into account, I mean, the city already came up with this idea to replace this street with permeable pavement. They put the swale in there to collect rainwater. And this has really served a number of purposes. It's obviously reduced any urban flooding in this area. It's reduced runoff going into the MS4 to the Spokane River. And also, if you know Spokane draws most of its water. Actually, most of the population in the valley gets their water from an aquifer. It's the Spokane Valley Aquifer. So really good example, I think, of a multi-benefit type stormwater project. But again, this is something that I think is supported by this model that we have for urban flood risk. And I think it's just a great example of like projects that the city could be doing. And then likewise for your cities, you know, Sacramento or wherever you might be from. Okay, so what can we take away from this? First off, resiliency planning should include the social risk, not just solely the physical risk of urban flooding. Considering those areas of population that are more at risk, more vulnerable, don't have the access to opportunity that other parts of the community do. Secondly, it's a good idea to take a look at any natural areas that can be used for flood mitigation and try to preserve those balancing those, of course, with community growth is very, very important. And then last, adapt plans accordingly to preserve those green spaces, to look at new type of stormwater projects, specifically green infrastructure projects. Okay, ran through that pretty fast, obviously, but that is what I have, and I would really invite your questions at this point.
Awesome. If you have any questions, go ahead and put them in the chat, and we'll give you a couple minutes to do that. But thank you so much, Doug. That was really informative. What an awesome workshop.
Yeah, you're welcome.
And while we're waiting for questions to come in, you can either unmute yourself, put them in the chat for those that are just joining. But we also have a couple more workshops coming up today. We have one at 11 o'clock with Brandon Rosenboom, the writer of the new construction general permit. And then we have one on municipal good housekeeping and pollution prevention that starts at 1 p.m. And then an illicit discharge detection and elimination training that starts at 2:30. And all of those are Pacific Standard Time. So be sure and join those. And you can find all of that information on our website.
Hey, Rebecca, if anyone doesn't have any questions just yet, I did want to take this opportunity, as I think Rebecca said was fine to do, that Storm Sensor is a company that, this is one of the things we do is the risk planning using this model. If you know about our company, we also have some other solutions. Our core solution actually is a network sensor solution where we install flow sensors out in a stormwater or even sanitary systems to measure real-time data. We can bring that data into our analytics software and use it as a tool for operational purposes to alert for flooding events, potential flooding areas. We also have clients that use this data more to validate models, to do capacity planning. So there's a lot of potential applications with our sensor-based solution. And what I showed you today is kind of for some cities, kind of a precursor. It's kind of identifying where your areas of risk are. And then based on that, you may want to consider doing some active flow monitoring in those areas so you can get the hard data that you need to support and justify projects. The third thing we do is we can do capacity planning and analysis. So we can actually look at places where our sensors are installed, bring that sensor data in, as well as other climate type data, weather data, even tidal data, and we can do storm analysis. We can look at particular storm events and help you kind of know how your system is able to respond from a capacity standpoint. We've done this for cities like Norfolk, Virginia, where it's a very low-lying area. They have found that even during non-storm events, their pipes are sometimes 50% full on average, and a lot of that is due to tidal influences. So those are some of the things we do. If you want to talk with me at some point, I've got my email down there at the bottom, and you can certainly probably get my contact information from Rebecca or one of the other organizers.
And it looks like we have a question from Cliff, and he said, how do we reconcile or assess the relation between high property values and socially vulnerable areas? The vulnerable areas usually are low real estate value.
Okay, yeah, it's a good question. Yeah, I don't know if I have a full answer on that for you, Cliff. What city are you with? Did he say?
No, he didn't say.
Oh, okay.
Cliff, if you want to answer that, you can go ahead and put it in the chat. Doesn't look like there's an answer quite yet.
Oh, okay. I thought I heard someone talking there. So you're talking about low, he said low property values, but high risk?
High property values in socially vulnerable areas.
Oh, I see what you're saying. Yeah. Oh, okay. That makes more sense. Yeah, the property value is like based on an appraised value. So like some of those properties in Spokane, the first example I showed you all, even though there's a lot of social vulnerability in there, there's a lot of, and I've seen it firsthand. I was just in Spokane a couple of weeks ago. The property values are very, very high in that core area. So that apartment building that flooded, that's, I think, considered a high property value in terms of what its potential worth is if it were to be torn down and built up with a condo or something like that, or mixed type of property. Does that help, Cliff?
He just put in the chat saying he's a retired environmental scientist from a remote rural area. Not trying to do a gotcha, just how to balance those factors.
Oh yeah, right. Yeah, no, it's a very delicate process, I think. And I know from my research that some cities, will buy up some properties. I think Roseville is a good example of that I mentioned earlier. I think one of your drainages is there in Roseville. Is it Lee's Creek? Is that right? I can't remember the name of it, but somewhere along the lines after those large flooding events in '86 and '95, Roseville really made a concerted effort to look at properties that they could potentially return back to their natural state.
Awesome. Well, it doesn't look like there's any other questions, so we might let you guys go early so that you can jump on the next workshop if you want to. But again, you can find all that information at stormwaterawareness.org. And thank you so much for participating in today. It's because of people like you that this event is made possible. So thank you, Doug, for presenting, and thank you everyone for attending.
Yeah, thank you, everyone.
All right, take care.